Right. Okay. What we have discussed up to now is the electricity, right? The currently again kind of valid topic and timely topic. Neither. It's a valid and timely topic because we are also having problems these days related to this electricity and how we can produce electricity. All these things are very important to us. Actually, how I'm accessing internet now is also due to the alternative power backup system that I'm having. Actually, I'm using solar system. The reason is currently also I don't have power in my place. So maybe you are facing similar situation. Anyway, this is really required. What we have learned last day is basically about electric basic theories about these insulators and also conductors. We just discuss about that, and we learn about the parallel and serial connection of the bulbs. Can you remember which gave us more brighter one? So which is more brighter? Is it a serial connection or is it a parallel connection? Which gave us brighter result? Right? So we just learned this last day. Okay, here let's think this battery is sharing 9 volt. Battery එක 9 volt දෙනවා කියලා. This battery is sharing you 9 volt. Then this 9 volt is shared among these. That means each of this will get 4.5, 4.5. Right? Here also, let's say the battery has 9 volt. Then this one is also getting 9 volt and this one is also getting 9 volt. Means this bulb, so this is in between this also you can see 9 volt. And in between this also you can see closer to 9. This is not really 9 volt, but closer to 9 volt. Why closer to 9 volt? Because in any kind of circuit, there's something called resistance. හැම circuit එකම resistant එකක් තියෙනවා. පොඩි බාධාවක් තියෙනවා. හින්දා 100%ක්ම අපි වෝල්ට් 9ම හම්බ වෙන්නේ නැහැ. චුට්ටක් අඩු වෙන්න පුළුවන්. බැටරි ටිකක් වැඩියෙන් තිබ්බොත් සමහරට අපිට 9 වෝල්ට්ම ලැබෙන්නත් පුළුවන්. මෙතනදී 9 වෝල්ට් බෙදෙනවා දෙකට. මොකද serial connection එකක්නේ. ඒ හින්දා serially connect වෙන හැම component එකකටම බෙදෙනවා. 4.5 වගේ ආසන්න වශයෙන් බෙදිලා යන්නේ. එතකොට bright වැඩි වෙන්නේ මොන setup එකද පුතේ? Which setup is more brighter? Is it number 1 or number 2?
Number 2, sir.
Number 2, right? The parallel setup is more brighter. But if you take the time that we can use the setup, it will be like when voltage is high, what will happen? Voltage means we learned that is the potential difference between the lowest and the highest. The voltage can හරියට දියැලක් ගත්තොත් ඒකේ උස වගේ. ඒතර උස වැඩි වෙන්න මොකද වෙන්නේ? අපිට වතුර වේගෙන් වැටෙනවානේ. right? ඒතර voltage එක වැඩි වෙන්න අපිට එන මේකේ මේ power එක වැඩි. ඒකයි මේ වැඩිපුර brightness එකක් එන්නේ මේ bulb එකට. When the height is more, there will be more power. That is why you get this. Right? In the other hand, the amperage means amperage කියලා කියන්නේ මේ ධාරාව නැත්නම් කොච්චර current එකක් මේකේ යනවාද මේ යන pipeline එකක් හරි what line එකක් කියලා හිතමු වතුර එකක් කියලා මේකේ. So when you take section, horizontal section, the amount of electrons or amount of power is called the amperage. එතකොට amperage එක කියන්නේ කොච්චර මේ වැටෙන උස නෙවෙයි එක තප්පරයකට හෝ එක කාලයකට මේකෙන් යන ඉලෙක්ට්‍රෝන ප්‍රමාණය ධාරාව කොච්චර power එකක් යනවද කියන එක. That is called amperage. Amperage වැඩි නම් මොකද වෙන්නේ පුතේ? So let's say this battery is let's say this battery is having 2 ampere hours, 2Ah, and the same time this battery is having 10 ampere hours, 10Ah. So what do you mean by this 10Ah? ගොඩක් වෙලාවට battery එක තියෙන Ah කියලා ampere hours. More than ampere hours, what will happen? ampere hours ගන්න නැත්නම් amperage එක වැඩි වෙන්න මොකද වෙන්නේ? We can use this for longer duration, right? මොකද මේ back මේක දැන් හැම වෙලේම අපි ගන්න ප්‍රමාණය මේ බල්බ් වලට අවශ්‍ය ප්‍රමාණය විතරනේ ගන්න amperage එක. එතකොට 2 ampere hours එකේ සමහරට අපි හිතමු මෙයා ampere එක ගානේ ගන්නවා කියලා. එහෙනම් ඉක්මනට මෙයා ඉවර වෙනවා. Within 2 hours maybe it's over. But here it will last for 10 hours. So when you have more amperage, you can keep the battery for longer duration. Higher the age, we can keep the battery for longer duration. We learn about them before, right? කලිනුත් අපි ඉගෙන ගත්තා ampere voltage කියන දෙක. So in these practicals also we have learned about that. Let me show this using our Tinkercad example. That is better place to try this. What happens when this amperage is high? Voltage can be similar. So let's try to design a new circuit. I have introduced this last day. You can try this with your computer too. But using mobile phone, it's quite difficult to do this drag and drop stuff. Therefore, please try this with your computer or laptop, right? So that will work. Computer එකෙන් හරි laptop එකෙන් හරි මේක try කරන්න. එතකොට අර මේ I'll send you the link. එහෙම try කරන එක මේ phone එකෙන් try කරන්න ටිකක් අර drag drop කරන්න අමාරුයි. කියන්නේ අරන් දාන්න අමාරුයි මේ කොටස්. Okay, let's have this kind of setup. All right, one is coin cell battery. So can you see what is the voltage of this battery? Hello, are you there? What is the voltage of this battery? Mugi, can you hear me?
Yes, sir.
Okay, can you see the voltage? It is mentioned here, 3.0 volt. Can you see that? Is it visible to you? Can you see the voltage now?
Yes, sir.
Right. Okay. That is voltage, right? So what is the voltage of this battery?
One 1.5.
1.5 volt. Can you see? Both of you can see this, right? I hope both of you can see this. Then if I try to connect a LED bulb, so which bulb will be more brighter? If I connect LED bulb to this setup and this setup, the blue battery and the coin cell battery, which will be brighter?
The
Double A or coin cell. Voltage is, so I said the voltage is the gap between the minimum and the maximum. So higher the voltage, so what will happen? Higher the voltage, it will be increase the energy, so brightness will be high. Right, okay, let's see. So let's connect. This is a positive edge. I'm connecting that to the positive of this anode. This is the negative. I can add a switch, but I'm directly connecting. Same time, this is I'm connecting this setup to. This is easy, positive and negative. So let's see. Can you see which is more brighter?
coin battery, sir.
Yes, coin cell battery is more brighter, right? So this one is not much brighter. When you go there, you can see it's even giving 61.9 milliamperes, which is more than the required milliampere rate. Ampere ganath make it varying enough, 6.9 milliamperes. So how can I make this second setup 3 volt? මට දෙවන එක 3 volt කරගන්න පුළුවන්ද? පුළුවන් නම් කොහොමද?
You have to change. We have to put the negative side on the positive side and the positive side on the negative side.
එහෙම voltage එක වැඩි වෙනවද? If I change the positive side and negative side, will it be higher?
We need to add another battery.
Yes, we need to add another battery. That is what we have to do, right? Make a positive negative මාරු කර diode එක පත්තු වෙන්නේ නැහැ පුතේ. Because diode will only transmit power only one side. Diode එක අනිත් පැත්තට transmit කරන්නේ නැහැ current එක. Diode එකේ විශේෂත්වය diode එකේ current එක යන්නේ එක පැත්තකට විතරයි. It cannot transmit current both direction, right? The diode එක diode කියලා කියන diode වල යන්නේ current එක එක පැත්තකට විතරයි. අනිත් පැත්තට current එක දුන්නට මුකුත් වෙන්නේ නැහැ. යන්නේ නැහැ current එක. ඒ තමයි diode වල හැටි. හරි දැන් මම මේක මොකද්ද කරන්න ඕන? I need to increase one more battery, right? I'm adding 2 batteries now. What will happen as a result? So this is first setup, this is second setup. What's the problem? Now, I have added 2 batteries. Now, since I have added two batteries, add karanna ona kohomada puthe? These batteries need to be added serially or parallelly?
Serially.
Serially. එතකොට මෙයාගේ plus එක අපි connect කරන්න ඕන මේ battery එකේ මේ බලන්න. මේ තියෙන්නේ minus එක. හරි? එතකොට මේ තියෙන්නේ plus එක. මේ plus එක අපි connect කරන්නේ අනිත් battery minus එකත් එක්ක serially. එතකොට මෙතන තියෙන්නේ plus එක. හරි? ඒ කියන්නේ battery කැලි දෙකක් තිබ්බොත් ඔයාලා දැකලා තියෙනවනේ නේද මේවා torch වල එහෙම දාන්නේ battery කැලි දෙක කොහොමද? සෙල්ලම් බඩු වලත් දානවා. මෙහෙම දානවා පළවෙනි එක. එතකොට ඒකේ ධන එකට පස්සේ මේ ඊළඟ එකේ ඍණ එක තියන්න මෙහෙම දාන්නේ නේද battery දෙක. Have you seen this?
Yes.
Then this is negative, this is positive. මේ විදිහට තමයි දාන්නේ. එතකොට මෙයා 1.5 volt නම් මෙයා 1.5 volt නම් දෙන්න එකතු වෙලා කීයක් දෙනවද? What is the total?
3 volt.
Total will be 3 volt. Hari? I thought here also 3 volt, here also 3 volt. So what's wrong with this? Why this is going to be, why this bulb is going to burn? මෙයා දෙන්නේ 3 volt. මෙයා දෙන්නේ 3 volt නම් ඇයි මේ bulb එක පිච්චෙන්නේ? මෙතන මේ කියන්නේ bulb එක පිච්චෙනවා කියලා. Here, can you see what is the milliampere level? Read the milliampere level.
Too powerful.
Yes, what is the milliampere level this setup gives? Read this.
Current through the LED is 136 mA, while absolute maximum is 20.0 mA.
MA means milliampere, right? Okay. So that means what is the milliampere range? Milliampere කීයක් වෙනවද? 136ක් වෙනවා නේද? 136 milliamperes. කීයක්ද යවන්න පුළුවන් අපිට bulb එකෙන්? The maximum that we can send is 20 milliampere. 20 milliampere යවන bulb එකට දැන් අපි දීලා තියෙනවා කීයක්ද? 136. It cannot tolerate, so bulb will burn, right? Bulb එක පිච්චෙනවා. එතකොට බලන්න මේකත් 3 volt. This setup is 3 volt, right? This setup is 3 volt. This setup is also 3 volt. But this setup gives 136 milliamperes. This setup gives කීයද මෙයා දෙන්නේ? මෙයාත් දෙනවා වැඩි ඇත්තටම. So here 61.9 milliamperes, right? This setup gives 60. මේවා practicallyම තේරුම් ගන්න පුතේ. දැන් මම අර අතන කියලා දෙන්න පුළුවන්. හැබැයි එහෙම තේරුමක් නැහැ. ඊට වැඩිය හොඳ මේක ඇත්තටම practically දකිනකොට when you know this practically it's easy, right? You will know that 61.9, right? Here 61.9 milliamperes. So what is the solution now? Right? Then ප්‍රශ්නයක් තියෙනවනේ නේද? දැන් voltage එක නම් ප්‍රශ්නයක් නැහැ. So both will supply 3 volt, but the problem is one will give more milliampere and the other one will give less milliampere, but still both are high, but this is too high. My right side solution has too high milliampere, so it will burn the bulb. So how can we control that? දැන් ampere ගන්න අපි හිතමු මෙහෙම බටයකින් අපිට දැන් මෙහෙම වතුර බටයක් තියෙනවා පුතේ මේක හොඳට හිතලා ගන්න, right? Think carefully. So if we have a pipe like this, right? This pipe gives us water. Let's say this pipe sends water. මේ pipe එකෙන් වතුර එනවා, right? So how can we control the amount of water? Amount of water is basically, you know, the amperage now, right? When this, okay, let's say there's a small pipe and a larger pipe, which will give us more water. So is it smaller pipe or larger pipe? කොයි pipe එකෙන්ද අපිට වතුර වැඩිපුර එන්නේ පුතේ? චූටි pipe එකෙන්ද ලොකු pipe එකෙන්ද?
ලොකු එකෙන්.
ලොකු එකෙන් නේද? එතකොට මේකෙන් තේරුම් නැත්නම් කියන්න ඕනේ මේ මේවයි මේ අපිට මේ pipe දෙකක්. මේ pipe දෙකෙන් වතුර එනවා. මේක tank එකක් කියලා හිතන්නකෝ. This is a tank and this is a tank, right? එකම size එකේ tank දෙකක් තියෙනවා. එතකොට මේකෙන් වතුර වැඩිපුර එනව නේද? මේකෙන් වතුර අඩුවෙන් එන්නේ. මේකෙන් වතුර වැඩිපුර එනවා. This second setup will give more. එතකොට ඉක්මනට tank එක හිස් වෙන්නේ කොකේද? Which tank will be empty quickly?
The first one, sir, because
First one or second one, which will be empty quickly. So second one supply more. Second one supply more power. The power anyway. Second one supply more water. And since this pipe is larger, it will be empty soon. Right? Okay, think similar. Yeah, then similar setup. This is like a small pipe, and this is like a large pipe. So how can we control this water? Then we water කොහොමද අපි control කරගන්නේ? Yeah, if we do something like this, what will happen? Then මෙහෙම තියෙන pipe එක. So we have a larger pipe now. What if we make it smaller like this? Then will it do my task? Will it be slow down the water flow?
Yes, sir.
Yes. Have you seen syringes? Syringes දැකලා තියෙනව නේද?
Yes, sir.
Syringe. Right? I think syringe, you have seen the syringe pumps. Right? So what is actually happening here? So you can see large volume is inside the syringe, right? But by using the small thin needle, what it does? It will control the flow. නේද? නැත්තම් මේ syringe එකේ තියෙන ඔක්කොම ටික අපේ ඇඟට එකපාර ගැහුවොත් එහෙම අපේ blood මේ අපේ මේ වලට veins වලට veins නෙමෙයි අපේ blood vessels වලට එක දරා ගන්න බෑනේ නේද? වැඩිපුර එනවනේ. එහෙනම් මොකද කරන්නේ? ලොකු මේව එකක් තිබ්බට අපි චූටි pump එකකින් තමයි මේක ගන්නෙ නේද? That is what done here. එතන මෙයාගේ කොහොමද අපි electronic වලදී එක කරන්නේ පුතේ? How to do this in electronics? How can we make this pipe thinner or make it smaller? දැන් මේක නම් දැන් මේ pipes වල නම් මේක කරන්න පුළුවන්. මේ බටේ පුංචි කරන්න පුළුවන්. ඔයාලා දැකලා ඇත්තට T junction තියෙන T socket තියෙන. මේකට socket එකක් ගහලා මේකට චූටි valve එකක් දාලා මොකද කළා චූටි කරන්න පුළුවන්. Tap එකක් දාලා control කරන්න පුළුවන්. Tap එක හරියට switch එකක් වගේ. We can control this in pipes. How to control this in electronics?
With the resistor.
Yes, very good. We can use a resistor. That is the solution, right? Let's use a resistor now. So I'm going to connect the resistor serially. Resistor will slow down my current flow. Okay, let's see this. Connecting a resistor. What will happen actually in the serial connection? We learn the voltage will be shared. The voltage is shared. This will take some voltage and this will take some other voltage. Therefore, the flow of current will be slower. So let's see now this. And you can see now this has reduced. This is not going to burn. Let's reduce this. I'm going to put in this symbol. What is this symbol? This is called. Do you know this name of this symbol?
Can't remember, sir.
Ohm. This is called ohm, right? Ohm කියලා කියන්නේ මේකට. Ohm වලින් තමයි මොනවද මනින්නේ? Ohm is used to measure resistance, right? Ohm is used to measure resistance. 1 ohm, not enough. 10 ohm. 10 ohm, still not enough. 38. Let's make it 20 ohms then. Ohm විස්සක් විතර දාලා බලමු. Oh, still 28. Ne, the Vissane Puluan Kama, we see attack final. Likewise, you can control, right? So then 30 ohms. Now, you see the guy high. Achutta Kadukarana, 35 ohms, 36 ohms. Oh, 20.1, 37 ohms, 38. Oh, now the problem solved, right? 38 ohms. Actually, let's put somewhere around 40 ohms, round figure, right? 40 ohms. Now this is under our control. 40 ohms or 50 ohms, 40 ohms, something like this. Now this is under our control. So let's add the similar thing, similar way. I'm going to add a resistor here. Connect like this and this, on it. You can see less volt because I have added, what is the ohm? This is like 1 kilo ohm, that is too heavy. ohm. Let's add 100 ohms. Oh, that's enough. Let's add 60 ohms. Not enough. You can see 75 milliampere. Oh, sorry, 60. Oh, it's enough, right? Having 60 ohm is enough to control this. Can you see? So let's add 50 ohms. It's enough, right? Let's add 40 ohms. No, not enough because 22.1. No. Then 45 ohms. 20.1. I think you need to add at least 50 ohms to control that. So maybe 47 ohms like will work, but 50 ohms will control this. Okay, now you know little bit of electronics, not everything, but at least you can understand some basic principles. Okay, so what is voltage, Pute? Voltage is the gap between the lowest and the highest, right? Higher the voltage, it will increase the energy. Right? Higher the voltage, වැඩි වෙන්න voltage එක කියන්නේ මෙහෙමයි. දැන් අපි හිතමු කවුරු හරි අපිට ටොක් එකක් කරනවා කියලා. එතකොට ටිකක් ඈත ඉඳන් නිකන් අපි හිතමු මේ මීටරයක් විතර උඩ ඉඳන් ටොක් එකක් කරන්න යන්න කියලා. එතකොට රිදෙනවා වැඩිනේ. අපි අත දිගෑරලා ටොක් එකක් කරනවා කියලා. ඒතකොට රිදෙනවා නේ සෑහෙන. ඒ වගේ තමයි මේ voltage එක වැඩි වෙද්දී. දැන් ඔයාලට මේ බැටරියක් ඇල්ලුවම කරන්ට් එක වදිනවද?
No, sir.
No, we will not get spark, right? We will not get shock, electric shock when touching this kind of battery. So what if you touch 230 voltage? That is 230 voltage කියන්නේ අර ගෙදරට එන AC current එක. අර ඒ plug එකක් ගෑවුනොත් එහෙනම් මොකද වෙන්නේ? You will get electric shock නේද? එතකොට 110 වගේ ලොකු voltage සාමාන්‍ය 100 ගාණක් වගේ හැල්ලනකොට spark වෙනවා, current එක වදිනවා. හේතුව මොකද්ද? අර මං කිව්වේ දැන් කවුරු හරි ඔයාලට නිකන් අර මිලිමීටරයක් විතර ඈතින් නම් ටොක් එකක් අරිනවා. ඔයාලම ඇනගෙන බලන්න. මිලිමීටරයක් විතර ඈතින් පුළුවන්ද? So will you feel? නෑ නේද? එහෙම රිදෙන්නේ නෑනේ නේ. මිලිමීටරයක් ඈතින් ඒ චූට්ටයි. බෑනේ රිදෙන්න ගහන්න බෑ. So it's like this low volt battery. You will not get electric shock. But if it is like 1 meter, if it is like 230, then you will get. What about 10,000 or 11,000? අර යන්නේ high tension line වල 33,000, 11,000, what will happen?
Die, sir.
It is definitely, it will kill, right? It will kill. And have you seen that අර කපුට හැම සමහරලාට හැප්පෙනකොට දැකලා දෙනවා පුපුරලා යනවානේ.
Yes, sir.
සත්තු
Sir.
ඔයාලා දැකලා තියෙනවද මේ අර වවුල එල්ලිලා ඉන්නේ වයස් වල මැරලා? Because like that is a heavy voltage. සත්තු මේ වුණොත් ටොග්ගල් ලොකු සද්දයක් එනවා. ඒ තරම් blasting because that is very high voltage. The voltage වැඩි වෙන්න එහෙම තමයි වෙන්නේ. Right? You need to understand. And higher the ohm, you can control. You can see here I have used only 40 ohms. That has controlled this circuit. Here I have used 50 ohms because it has given more power. I have controlled that with 50 ohm resistor. Any resistors are needed to control the current flow. Current can be controlled by using resistors. We can measure this using a multimeter. We'll make a multimeter. If you use a multimeter, so see here. So this bulb will get. So what is the voltage? So let's see what is the voltage around this resistor. So it gets 747 millivolts. So 747 millivolts. If I connect this to the bulb, the other side, cathode, you can see it gets 2.81 volts. Why? Because the bulb and resistor both get. And if I connect this to, so let's connect this to the bulb only, bulb will get closer to 2 volt. Because you can see around 1 volt, you have to share with the resistor. Because this is serial connection. In the volt එකක් විතර මෙයා use කරනවා. ඊටු දෙක මෙයාට හම්බ වෙනවා, right? Okay, let's check this situation the other circuit. In the other circuit, let's see the situation. Moving this here. Let me erase these things. Please remember, right? I have erased, but please remember these things. Right, let's check the resistance voltage here to here. So what is the voltage? You can see it is closer to 1. So this is 900 millivolt, means closer to 1 volt. එතකොට මෙයාටත් එහෙනම් 2 volt වගේ හම්බ වෙන්න ඕන. මොකද ඔක්කොම තියෙන්නේ 3 volt නේ. So here if I measure the voltage of this one, you can see it's 2 volt, right? 2 points. Okay, both bulbs will turn on with the 2 volt setup, and so that will get a controlled current too. Therefore, bulbs are happy. 20 milliamperes. The current through the bulb is 20 milliampere current through the circuit. How to measure the amperage? In order to measure the amperage, you need to connect this way. You need to connect this. And let's say I need to measure the amperage. You can see it's taken closer to 20 milliamperes. So when there are 20 milliamperes, the bulb is happy, it will not burn. To measure the amperage, you have to connect like this, right? Let's start the setup. Let's see the amperage of other circuit too. Because parallel connection can measure the voltage, serial connection can measure the amperage. Serial connection from this one to this one, then you can measure the amperage. Again, 18.7 milliampere, so bulb will not burn, right? So if you measure the voltage, you can see the bulb will get 2 volt, closer to 2 volt. Bulb will get closer to 2 volt, so bulb will turn on, and you can see the light. And also it will get closer to 20 milliamperes. No need to remember these figures, but you need to know what? You need to know how to connect these devices, right? How to measure the amperage and how to measure the voltage. Actually, we learn about the insulators and conductors. Conductors are sending current. Conductors are actually transmitting current. Why conductors transmitting current? I said that there are free electrons. These free electrons are moving from one to another. Therefore, it can transmit current, especially these metals. Not every metal, but most of the metals are conductors. Conductors can සන්නායක. සන්නායකවල තියෙන නිදහස් ඉලෙක්ට්‍රෝන. හරි නිදහස් ඉලෙක්ට්‍රෝන. මොකද මේවා අන්තිමට හැදෙලා තියෙන පරමාණු වලින් පුතේ චූටිම දේ පරමාණුනේ. ඒක තියෙන ඉලෙක්ට්‍රෝන කියලා දෙයක්. එතකොට ගොඩාක් වෙලාවට මේ ලෝහවල තියෙන නිදහස් ඉලෙක්ට්‍රෝන. Most of the metals will have this free electrons. This free electrons will move. Free electron යනවා කියන්නේ ඔන්න කරන්ට් එක යනවා. Free electron යන්නේ ලෝහ වලින් විතරද? Is it only through metals, or is there any other ways of transmitting electrons? වතුරෙන් අපිට කරන්ට් එක වදිනවද පුතේ?
Professor.
The වතුරට කරන්ට් වයර් එකක් වැදිලා තිබ්බොත් වදිනවද අපිට කරන්ට් එක?
Yes, sir.
Yes නේද? ඒ කියන්නේ වතුරෙන් ඉලෙක්ට්‍රෝන යන්න ඕනනේ. නැත්නම් වදින්න විදියක් නැහැ. Yes, water is also pure water is not, but like distilled water is not. But the thing is, very little amount it transmit. But normally water will transmit electrons. In the water harat electron in the pulam, but it is not a very good conductor. The conductor way. But what are the like here? What are the conductors here? One of the conductors. Can you tell? See the list and tell me the conductors. Or tell me whether it is conductor or insulator. Outer casing of the wire. Is it a conductor or insulator? outer casing of the wire. Is it a conductor or insulator? Outer casing කියලා කියන wire එකේ පිට තියෙන පුතේ rubber එක. Rubber casing or plastic casing in a wire. Is it a conductor or insulator?
Insulator.
Insulator. I can current again. Wire wire in the core of the wire. Wire, copper wire, aluminium or copper wire or yes. Wire again, yes, wire is a conductor. A coin. Kasi. Coin, is it a conductor or insulator?
Conductor.
Wire is a coin is a conductor. That is true. Then okay, dry papers. Dry papers. Dry papers. Yes. Dry papers. Come on, yes, and tell me. Dry papers, is it a conductor or insulator?
Insulator.
Insulator. Shiny wrapping of the slab of a chocolate. Shiny wrapping of a slab of chocolate. A chocolate otala dina kole. What do you think?
Insulator.
It is a conductor, right? ඒකේ aluminium වගේ මේ එකක් තියෙන metal එකක් තියෙන්නේ. අර ඔයාලා දැකලා තියෙනවද ඒක ගුලි කරන්න පුළුවන් metal එකක් වගේ. Haven't you seen? Polythene එක නෙවෙයි සමහරට මේ shiny wrapping කියන එකේදී polythene wrapping එකක් තියෙනවා, but most of the chocolates, like originally it came with this aluminium. Here you can see chocolate. It is aluminium wrapping. That is how it was. Here this is, you can see here, aluminium foil paper, right? This is wrapping chocolate in aluminium foil. Normally it is a aluminium foil normally, but sometimes you can see, so there are, so this is normally aluminium foil, but sometimes it can be like non-aluminium, or it can be some plastic paper or transparent paper, can be, but normally it is this aluminium foil papers. So it is a conductor. මේව conductor. Sorry, making current එක යනවා. ඉස්සර පුතේ ඔයගොල්ලෝ මේ දන්නවනේ අර බල්බ් බැල් තිබ්බත් දැකලා තියෙනවද? වෙසක් එකට එහෙම දාන්නේ. මම හිතනවා ඔයාලා දැකලා ඇති කියලා. අර චූටි බල්බ් බැල් තියෙන මේ බල්බ් බැල් වලේ එක බල්බ් එකක් පිච්චුනොත් සමහරලාට මේකේ තියෙන සීරියල් කනෙක්ෂන් එක. එතකොට අනිත් බල්බ්ස් පත්තු වෙන්නේ නැහැ. හරි, අපි හිතමු මෙහෙම දැන් බල්බ්ස් ටිකක් තියෙනවන්න මේ වගේ මේ, let me show this. This is a circuitry diagram. So let's connect a few more bulbs, right? I'm going to connect few more bulbs. Okay, connect this in the sanugi mocker disconnect to now. Hari kamanne I had recording එක දෙන්න පුළුවන්. So let's connect more bulbs, LEDs, right? ඒතරේ bulb වල මේ වගේ තියෙන්නේ. මේ ධන එකට ඍණ එක තමයි connect වෙලා තියෙන්නේ. හරිද? ඊට පස්සේ මේකට ආයි මෙහෙම තමයි ඔවා තියෙන්නේ සාමාන්‍යයෙන්. So this is the serial connection of bulbs, right? එතකොට මෙයාව connect කරන්න වෙනවා. So it connected. current එක මදි. So that's the problem, right? So let's increase the number of batteries. 4 batteries, right? 3 bulbs. Can you light up 3 bulbs with 4 batteries? Okay, enough. So what about 4 bulbs? I think it's not enough. Not enough. So we need more powerful batteries. So only support 4 batteries. Let's take some another set of batteries, right? Okay, I prefer to have 9-volt batteries. Well, because it can provide more voltage. Positive. Positive 9-volt is not enough. So I need 2 of this. Little one. 18 volt is too heavy. Right. So let's add more bulbs. Bulb better bulb bone up. $18 means at least we can put 1, 2. එකක් 2 වගේනේ ගන්නෙ 2 එතකොට 18 කියන්නේ 9ක්වත් පුළුවන් 1 2 3 4 5 6 7 8 10 9 because 1 will take closer to 2 no 2 volt එකක් දෙක 2 volt වගේ ගන්න. Okay, let's connect this, let's connect this, and connect this. Okay, right now you can see this is okay because one will take closer to 2 volt, so all bulbs are happy. They can, but what will happen if one bulb burn? So let's make this bulb like this. Bulb is not working. It's this bulb may bulb එක පිච්චෙනවා කියන අතර මේක වැඩ කරන්නේ නැහැ. I'm going to delete this bulb. So what will happen to the circuit? Will it work or will it not work? It will not work. Right? It will not work. See, in the middle, one bulb is burned, so the circuit is not working. Now, what can we do? Can you suggest me what to do? Hello. Can you suggest me what to do in this situation? Yes. මොකද්ද කරන්න පුළුවන් පුතේ? දැන් එක බල්බ් එකක් වැඩ කරන්නේ නැහැ. දැන් මෙතන බල්බ් එකක් කලින් තිබ්බා. හරි මෙහෙම තිබ්බා. එතකොට වැඩ කරා. දැන් මේ බල්බ් එක පිච්චුණා. නැත්නම් මේ බල්බ් එක අයින් කරා කවුරු හරි. මේක දැන් වැඩ කරන්නේ නැහැ. දැන් බල්බ් වල කැඩිලා. How can we fix this? කොහොමද අපි මේක fix කරන්නේ? දැන් ඔකට practically ඉගෙන ගන්න ඕන පුතේ science. නැත්නම් වැඩක් නැහැ. You should know how practically this is working. What should we do now?
කලින් බල්බ් එක තිබ්බ දැනින් තව වයර් එකක් දානවා.
ඔව් මෙහෙම අපිට වයර් එකක් දාන්න පුළුවන් නේද මෙන්න මෙහෙම. හැබැයි මෙතකොට පොඩ්ඩක් කරන්ට් එක වැඩියෙන් යනවා. මොකද එතන බල්බ් එකක් නැහැනේ. එතන චුට්ටක් කරන්ට් එක වැඩියෙන් යනවා. But still it will be okay. Your solution is okay. සාමාන්‍යයෙන් මෙතන තියෙන්නේ අර චූටි නිකන් දැන් බල්බ් එක නැතිකොට හෝල්ඩරේ විතරක් තියෙනවා. හරිද? මම මෙතන අඳින්න. මේක නෑනේ මෙතන පෙන්නන්න බෑනේ. දැන් මේ බල්බ්ස් ගහලා තියෙන හෝල්ඩර් එක නම් හෝල්ඩරේ විතරක් මෙහෙම තියෙනවා. මේවා ඔක්කොම හෝල්ඩර් වල තියෙනවා කියලා හිතමු. This is a holder, this is a holder, this is a holder to hold the bulb, this is a holder to hold the bulb, this is a holder to hold. These are holders, right? These are holders, but here you can see the bulb. The holder is there, but bulb is not there. So normally අර අපි කරන්නේ පුංචි කාලේ අර මේ චොක්ලට් කොලේ තියෙන ඔය ඇලුමිනියම් ෆොයිල් එක. ඕක අරගෙන ගුලි කරලා දානවා මේකට. ඔය ඇලුමිනියම් ෆොයිල් එක ගුලි කරලා මේ හෝල්ඩර් එකට දානවා. This is not a good thing, but පරිස්සමෙන් ඔයා ඊට පස්සේ ඔයගේ ඒවා කරන්න ගිහිල්ලා මෙහෙමයි මේක කරන්න පුළුවන් when bulbs are in the serial connection, then only you can do, especially these like bulbs in the bulb chain of bulbs. If both those bulbs are in a serial connection, you can do. එතකොට මේකට අර aluminium foil එක ගුලි කරලා ගහනවා chocolate කොලේ. Then what will happen? Actually, this is a conductor. Aluminium is a conductor, so this will connect that. Here the connection will be completed. Therefore, after that the bulb is working. දැන් එක bulb එකක් නැහැ, bulb එකක් ගන්න සල්ලිත් නැහැ. කොහොම වැඩ කරනවා අපි? චූටිනේ. මේ අපි අතේ සල්ලි නැහැනේ. ඒ හින්දා ටක් ගාලා chocolate කොලයක් අරගෙන ඔක ගුලි කරලා ගහනවා මෙතන. Then that is a conductor that will connect the bulb chain and it will work. Okay, just a practical example. Carbon rod. So remember that the chocolate wrapping is a conductor. Carbon rod of a dry cell. Carbon rod of a carbon rod is it a conductor or insulator? Yes. Carbon rod is a, so remember that the carbon rod is a conductor. Carbon rod the carbon rod පුතේ මතක තියාගන්න, why carbon rod is a conductor. You should remember in a battery you can see there's a carbon rod. So it will conduct. Dry wooden blocks, insulator. Rod of a pencil, again that is a carbon rod. Rod of a pencil is a carbon rod. So therefore it will again conduct. Plastic is insulator, polythene is insulator. The metals carry electricity are called conductors. The metals which do not carry electricity are called insulators. All right. So then, right, you can see here, you can see electronic circuit. In the electronic circuit, what are the appliances that you can see? Can you tell me, can you name the appliances you can see in this circuit? What are the components? Make it තියෙන්නේ මොනවාද? Tell me, actually send me a list of components. Okay, let's surely do this. Send it to the chat. Chat එක දෙවන්න බලන්න. What are the things that you can see in this circuit? Send it to the chat, please. Right. I got your answers. And diodes, yes. So diodes, you can see diodes. Diodes are basically a special circuitry equipments which will allow you to send current only one direction. So some diodes are emitting light. We call them light emitting diodes. සමහර diode වලින් එළියක් නිකුත් කරනවා. ආලෝකය පිට වෙනවා. අපි ඒවට කියනවා light emitting diode. සිංහලෙන් නම් ආලෝක විමෝචන diode කියලා කියනවා. These LEDs are kind of diodes emitting light. Right? Then the transistors. Transistors are actually like gates. These gates are opening based on certain logics. So still we are not to learn these logics behind these gates, but we will learn this in our future grades. So where these transistors are acting like, gates. These gates can be open or closed based on a certain condition or certain amount of current. So these gates can be open or these gates can be, that is kind of a gate blocking current some instances, and sometimes it will allow the current to pass through. So that is what the transistors are. And you can clearly see integrated circuits or ICs. So these are these large modules. Let me show, let me color. This is IC. These are ICs. right? These are ICs. Right, diodes are there, ICs are there. Actually transist inside these ICs, you cannot see the transistors, but these ICs are created with transistors. May IC හැදිලා තියෙන්නේ. ඒ වගේ ඇතුලේ තියෙන transistors. ඒතර transistor පේන්නවා කියන්නම බෑ. පේන්නක් තියෙනවා. But really you can see, but mainly ICs you can see. So what are these barrel like shapes? මේ barrel වගේ තියෙනවා මොනවාද මේ? චුටි චුටි නිකන් cylinders වගේ තියෙන. So what are these things? These are called capacitors, right? Dharitraka කියලා කියන අපි capacitors. It can store current for a short amount of time. These are called capacitors. These capacitors can store current for a short amount of time. Then TV වගේ එකක් ඒ වගේ powerful voltage මේ තියෙන එකක් CRT TV එකක් වගේ ගලවද්දි මේවා ගැන විශේෂයෙන්ම පරිස්සම් වෙන්න ඕන. Because these capacitors can store current. These capacitors can store high voltage sometimes. The voltage stored in the capacitor can be high. හැබැයි මෙහෙමයි මේකෙන් කරන්ට් එක වැදුන හැටිය ඒක යනවා. ඒක මේ කැපැසිටර් එකේ චූටි වෙලාවයි තියෙන්නේ. ඒකෙන් අපිට කරන්ට් එක වැදුනොත් කැපැසිටර් එකකින් ඊට පස්සේ ඒක අයින් වෙලා යනවා. ඒකෙන් එහෙම ගොඩ වෙලාවක් ඒ කරන්ට් එක තියෙන්නේ. Anyway, capacitor is used to store current for a short amount of time. So you can see capacitors, ICs, and conductors, several conductors which will send the current, diodes, right? Insulators which will block the current. All these things are there in this. Okay, let's learn about them one by one. Diode. So diode is basically a rectifying diode, a small bulb or trisel, and some piece of wire is there, right? So what it does, so diode, when you connect the diode, so to A and B, so you can observe that sometimes when you connect, let's say this side, right side and the left side, if it block the current, connect it the other way. So let me show that. Right? LED is one solution, right? LED is actually one solution that you can use. Let's use a normal bulb. Use a normal light bulb. And I'm going to erase other things. Erase. Let's take a bulb and a battery. 15 volt battery. Is it there? No. Let's take 9 volt battery. Is it there? Yeah. 9 volt battery is there. Let's connect this battery and the bulb. Terminal 1, terminal 2. You see bulb seams. You can see the bulb is lighting up anyway. So let's break the circuit using a diode. You can use light emitting diode or non-light emitting diode. This is a diode here. Connecting this side to cathode and this side to anode. Let's see what will happen. You can see the bulb is lighting up. The cathode is connected to the minus, negative, and anode is connected to the other end. Then the bulb lighting up. So let's use the diode. So this is Zener diode. So this normal diode is also okay. Let's connect this way now. Right. You can see still it light up. So let's use a normal diode. Let's see. Cathode. Anode. Yeah, you can see good light there. Then let's try to change that. Here, can you see? It's not sending the current. It's blocking the current. Earlier it sent the current, but now it's blocking the current. I have connected, but I have changed the edges. පැත්ත මාරු කරලා මම connect කරා. පැත්ත මාරු කරලා කනෙක්ට් කරාම මේකෙන් කරන්ට් එක යන්නේ. හැබැයි අපෝ මේක මෙහෙමම තියලා අපි පැත්ත ආයෙ මාරු කරමු. I'm going to connect this side. මෙයාව අනිත් පැත්තට connect. This is not a light emitting diode. I can use light emitting diode too. For this purpose, I can use light emitting diode. You can see it working. So let's use a light emitting diode now. Connecting cathode to this, anode to this. So this will block the current. It's not working. So let's connect the other edges. Let's connect the other edges. I'm connecting cathode here and anode here. Let's start the simulation. You can see it's sending the current, but this will burn because, like you can see, the reason is why it will burn. The reason is this will pass a big, like 1 to 5 milliamperes, and you have to control using resistor too, not just the diode. Diode will burn because of voltage, right? So these are special diodes, Zener diodes and photodiodes. These are special diodes. These are having special conditions. So, but in this grade, we are just learning about normal diode and LED, light emitting diode. Right, I think with that, you will have a better idea about diode. These are diodes. Rectifying diodes means these diodes are basically, so what is rectification? Rectification means selecting a direction. It will let the current flow in a certain direction. So here, this symbol is for the diode, standard symbol, because it's sending current this way, but blocking the current other. That is what the diode is. Right, you can see there is like 2 diode connection. I would like if you can experiment on this 8.11. Please do that experiment using our Tinkercad. So then what is the next lesson? LED, that we have already tested, right? Light emitting diode, we have already tested that. And LED has the special symbol, the diode symbol, but with 2 arrows, few arrows. Why? Because this diode is not emitting anything, but this diode is emitting light. Resistors we have learned. Yes, we learn about the ohm symbol. Also, what happened when the resistance increase and different type of resistors and the color codes of the resistors. So let's learn about that next day. And this is kind of, right? Let's learn about that next day. Okay, then. Right, I'll stop from here. One of our students joined recently. Let him come in, but the thing is, we have just going to wind up the class. That's the reason. Okay, then measuring this using like LDR, light here, LDR. So this LDR is basically light dependent resistors. So let's, it's kind of a sensor that we can use to detect the light. Okay, then yes, we have few topics to discuss. Okay, I'll discuss the remaining part next day, right? Up to 8 points. We can finish the lesson next week. Then week after next week, we have to discuss heat and its effects, right? I'll finish the lesson next week. Good night.
Good night, sir. Thank you, sir.
Good night.